So we're finishing up the backside of worksheet 8. You are looking at quadratic applications, and I'm going to warn you this lesson could be pretty difficult. This is your first exploration into some new stuff in PreCalc. So far we've been kind of doing reviewy stuff most of the time. So these are applications. We're eventually going to walk over to our calculator and make our calculator do the solving for most of these. This first one's the exception, simply because I'm going to help you set it up so we don't have to use our calculator. It'll be easier to solve it algebraically. So first, they're talking about a square base of like a piece of cardboard. Now we're going to make the lamest box in the world. They're going to take a square piece of cardboard, they're going to cut out little corners from it, and they're going to fold each of the sides up, and they're going to create this box that A, has no support because there's no overlapping, and B, has no top. So I don't know what you're making, but it's a box shape. So first thing you need to do for me is draw a square, which I can't do. So I'm going to do this. Where's a square? I don't think that's a square. Can we pretend this is a square? Pretend. Now, if it's a square, pretend, what do you know about the dimensions of that square? They're the same. Yeah, they're supposed to be the same. Mine don't look the same. The other thing that as I keep reading, it says we're going to cut out little corners from this box. So draw yourself little corners that you're intending on cutting out, and they should be the same size. In fact, I think they told you how big the corners are. What are they? 6. So this is a 6, this little guy is a 6, this is a 6, this is a 6. So is this. And so is this. So I wish I had a visual for you, but what's going to happen is the little red pieces are going to get cut out and folded up, and you're going to be left with a dimension of a box that stretches from here to here on this side and here to here on this side. And talk to me about what you just said about the dimensions of the sides of this box. They're the same. But the problem here is in our math problem, I don't know what they are. So in math, when you don't know what something is, but you got to give it a name, you usually go with a variable. Your choice?
L.
L. All right.
X.
No, you went with L. I'm going to go with L. It's fine. Doesn't matter. All right. So all these are L's, whether they look like it or not. So there's one clue. There's one numeric clue in this question. If you keep reading, it says, well, besides the 6 inches, it says the box needs to hold 1,000 cubic inches. What sort of a dimension measurement is that when it says cubic inches and it's what it's holding? That's fancy talk for volume. So now I need you to bring out your geometry brain. How does one calculate the volume of a rectangular prism? Length times width times height. Guys, I hate to break it to you, you have something to plug into place of each of the volume and the length and the width and the height. So for instance, the volume. You know what the volume has to come out to. It has to come out to 1,000. And then as far as the length and the width and the height go, this always bothers kids in geometry because depending on how you turn the box, like the length and width and height are subjective, I suppose. So since you went with L, let's call the length L. But the width is also L. And then the height would be, remember you're folding up these little pieces, these little red tabs. So it's 6 inches. Very good. What was your question, kiddo?
I would
You got it? Okay. So I know it doesn't look like it from the picture, but from here to here is some mystery length. And it's the same length as this because remember this was supposed to be a square. Mine doesn't look like a square, so we're using our imagination. All right, so if I look at the algebra here, guys, you have a 1,000. And then L times 6, better known as 6L squared. Now, normally I'd say, grab your calculator, let's graph it, except for this case, because this is a real quick 2 steps and you're done. We can solve this. Let's divide both sides by 6. And I'm going to need a little calculator help here, guys. What's 1,000 divided by 6? Thank you. And then it equals L squared, so your final step here is to square root both sides. And we're finding, now, would I have to put a plus or minus on this solution set?
No.
That'd be weird. Why would you have a length of a box that's negative whatever? 12.9 is it? Okay, so we are trained in math to be like, boom, find a variable and walk away, except not in this page because you got to read the questions very carefully. They don't actually ask me what L is. The question is, how big is the piece of cardboard? So go back to your cardboard piece, which is the original, what's supposed to be a square. Whoops. So from here to here, this entire green length, it's not L, it's 6 and an L, and another 6. So it's 12.9 plus 6 plus 6, which I'm hearing is 24.9. Very good. And inches was the label on here. So this piece of square cardboard is 24.9 by 24.9 inches. So I guess the moral of the story here, guys, is it's great to do the math and find the variable, but go back and read the question, because they very often don't want the variable. They want you to take it one step further and find something else about the picture. They could get crazy and be like, what's the surface area of your box? I'm not going to do that to you, but they could. They could ask you for a few other things. Question, we brought this up in the last class. Let's see if you guys have any thoughts on that. Did I have to call the blue piece L? I mean, obviously I could have called it a different variable. Was anybody thinking of calling the entire side of the cardboard like X? Like the big piece? We could have. If I called the entire side of the cardboard like X or L or whatever you want to call it, what would I have to have done to figure out how big the blue piece is then? Subtracted the 12. Very good. Yeah, so we would have had like X minus 12 for that little blue piece instead. Very good, very good. It would have worked out the same eventually, but I can tell you from experience of doing this question, that way is obnoxious and you have to use your calculator to quickly solve it. The way we did it created very nice math. So I went with the nice math. All right, it's a farm question, so you know what's good. Should we warn him that we're recording? We're recording. A farmer wishes to enclose 3 pens with fencing as shown. So he's creating what shape? A rectangle. Very good. He has 700 feet of fencing to work with. Now that includes the inner pieces of the pens as well. So it's not really a perimeter question as much as it is just a fencing question. What dimensions will maximize the area? So the fact that it says right here, I want to maximize the area, that means that when I get to my calculator, I'm going to need to find an expression for area, and that's what I'm going to have to program, and that's going to create, he's not here today, that's going to create a quadratic, and we're going to find the maximum of it. That's the point of this question. So a little note to self, if I want to maximize area, that means on my calculator, in Y1, I'm going to have to come up with an expression for area. Okay, that's the big goal at the end. We're not there yet. Let's talk about what we do know. Wow, like absolutely nothing. Like for instance, these little pieces that look like this, these green pieces, let's call them. There's 4 of them.
And they're the same length.
They are the same. I gotta call them something.
X.
X sounds wonderful.
W.
Whoa, getting crazy, man. All right, then I also see that there's one of these.
Okay,
And
so
it
you
matches
call
one of
it
those.
one.
I would.
Okay.
Because
I call
otherwise
it
you got
six-
a
I
whole...
call it 6.
You can, yeah. You can break them up into little pieces and it'll work fine. Your math's going to look a little different, but it'll work out to the same quadratic. So if I just call it one piece, again, I don't know a name, so I need to give it a variable name, not X this time. And could you do me a favor? Also, don't call it Y, because I'm about to move to my calculator who has its own Y, and I'm going to get really confused. So anything besides X or Y. A. Okay, that kind of reminds me of area, but whatever. Jeez. I should have said or A. Now you want to go with W. All right, there is only one numeric clue on this question. Do you see it? 700 feet of fencing. So if we were to add up all of those pieces of fence, so the 4 X's and the 2 A's, it's going to have to total to 700. I mean, technically speaking, up to 700, but he does want to maximize his area, so let's use all 700. Well, that's fantastic. Okay, break over here for a moment. How do you find the area of a rectangle in general? Length times width. So how do you find the area of this particular rectangle?
A times X.
Yes. Well, that's fun. My calculator is not going to allow me to go to y equals mode and have 2 variables. But I wonder if I could substitute.
Oh.
Like A, right here. Could you solve for A?
Yes.
Yes, you can. Subtract the 4x from both sides. So you have 2a equals 700 minus 4x. Go ahead and divide. Oops, that's a 2. You don't have to simplify this. Your calculator really doesn't care if you simplify, but it might be easier for typing later if we go ahead and divide everything by 2 like this. So y'all just found another way of saying A is 350 minus 2x. So this is a substitution trick, right, from algebra? Instead of x times A, my calculator wouldn't mind if I called it x times this. That's what I'm going to go to on my calculator. So in Y1, you're going to type in x times 350 minus 2x. Oh boy, this is going to be fun. And then we're going to have fun with the window. So don't graph it yet. Get rid of my, oops, answers from last hour. Said error. That's not good. What kind of error was it? Dimensions? It's probably your window.
Syntax.
Syntax? Okay, that means you have something typed in wrong. Go back to y equals. Are your plots turned off? And did you type x parenthesis 350 minus 2x?
Yes.
What?
Oh wait, I might put negative 2x. Yeah, I did.
Okay, that'd be it. All right, yes, ma'am. That's going to happen when we type in trig functions like sine and cosine and tangent. We're not going to do that till January. So any mode for me, for trig class, make sure you're watching your mode, but for me, I don't care. But anytime you reset it, it goes back to radian, so be careful about that. Guys, look at your picture. Hopefully your picture looks better than mine, but x represents what in this problem? These little green pieces of the fence. So if I think about appropriate places to look for my x, like at first, our calculator, when they're like reset, the x starts at negative 10. Is it appropriate to say the width of your fenced area is negative 10 feet? Yeah, that's weird. So 0 is an appropriate place to start. Now, as far as the maximum width, I don't really know. But remember, guys, we only have like 700 feet of fencing to go around. So I don't think the width is going to be crazy. Like, it's not going to be like 200 feet or whatever. So I don't know. Does anyone? I mean, I have 40 right now. I can just see if that works by hitting graph, but it probably, I don't know. I could cheat because I have the answer. It's not going to work. It's not going to work, man. We got to go bigger than 40.
100.
Bigger. 100. Let's go 100. Well, I only know that because I have the answer in front of me. I would have had to kind of play with this. Now, the y's, be careful. The y's in your calculator are your output variable. It's representing the area of the enclosed space. I really don't know. I mean, I could make some estimates and guesses, but what I'm going to show you guys is a trick that is like a platform. It's not the end-all be-all of window calculations. Since we've set up an X window that makes sense for our problem, you guys can try what's called zoom fit. So once you set up appropriate X's, so 0 to 100, then I want you to go to zoom, and then the 0th one, the 10th one technically, is called zoom fit. So you can either type a 0 or you can scroll down until you see zoom fit. That's actually not the greatest window in the world. However, what am I trying to find in this question? I want to maximize the area. Can you see the maximum of the parabola?
Yes.
Yeah. So technically speaking, I'm okay. Now notice what happens, guys. If I go back to the window, you don't have to do this step. But if I extend the window to like 300 for the X, and then I redo zoom fit, notice what the calculator just did? It readjusted the Y's for what it thought looked good. Turns out my X's were not a good window fit to begin with. So if this is what happens to you on a test and your teacher says, please give me an appropriate window, do you think this is an appropriate window? No, child. So you'd have to go back to window and be like, well, apparently 300 was way too big. So maybe pull that back to like 200. And guys, you're looking at a minimum enclosed area of negative 75,000 square feet. Does that seem like an appropriate place to start? No. What would a normal human start their minimum area at?
0.
0 makes sense. Okay. And obviously, if you write down this whole decimal for a maximum, I'm going to realize that you use zoom fit, and I'm not going to discredit you for that. But I am going to be sad if you give me a weird beginning of your window, like negative 75,000. Okay, so if I just adjusted that, I did a lot of work there I probably didn't have to do it. Because what's the whole point of this question? To find the max. So go find the max. So maximum, remember, we don't really like to scroll. We're trying to hop, right? So 100 is right in the middle of my window, so I'm going to bounce back to 50 for the left bound. I'm going to go 150 for the right bound.
Oh, I did 75.
Oh, dangerous. Let's try it again. And then for guess, I don't care, just hit enter. And I'm going to write down that entire ordered pair, and let's talk about what that ordered pair means, because that ordered pair means something. Let's round it to 87.5, comma, 15. What's the rest of it? 312.5? Okay. I know this is an XY ordered pair. But instead of calling this Y, do you guys remember what Y was calculating in this?
A.
It's area. What does X represent again? Go back to your picture. The width, or whatever you're calling it, for that one piece of fence. This is 87.5, 87.5, 87.5. What do they actually want from me?
Area.
The dimensions of the figure. So your figure is 87.5 feet by, well, how do you find this little red piece?
Divide.
How about that?
Sure.
Isn't that a formula for that little red piece?
Yep.
So 350 minus 2 times 87.5, which gives you 175, I believe. That is a nasty little question that shows up on your homework and your test. Okay. So you have to fill out the picture appropriately. You have to create a little tiny equation that you're going to substitute into the big equation. You got to go to your calculator. You got to find the maximum part of the parabola, and then you have to interpret what that maximum means. So guys, turns out if the farmer makes his fence over here 87.5 and this one 175, he's going to maximize his area at roughly 15,312 feet. Good job, farmer. These are important, need to know things. All right. I know, guys, that was a lot to look at. I'm with you. That's the worst problem on there, if that makes you feel better, okay? All right, a salesperson finds that her sales average 40 cases per store when she visits 20 stores per week. And then if she starts visiting additional stores, her average sales decrease. And that kind of makes sense. Like if you're a salesperson, if you're overextending yourself, you're going to lower your sales per store because you're not like as effective in every store. So let's put some information into a table, and then we're going to try to relate it to algebra so we can use our calculator. So like this first set of clues, her sales average is 40 cases per store, so that would go right here. If she visits 20 stores per week, so that would go right here. So to figure out her total cases, wouldn't we just multiply those numbers together? So in that particular instance, she'd be selling 800 cases. But then the next clue says if she visits an additional store every week, so like for instance, if she goes to 21 stores now, this number here is going to decrease by 1. So this goes down to 39. So let's see how that affected everything. It's still an increase. It goes up to 819. And we could kind of keep up with this pattern. You know, we could increase one more store to 22. That would knock this guy down to 38. And then it still would increase. But there's going to be a point in this math where the increases don't happen anymore. And we can either continue on with the table, which is not an effective use of your pre-calc brain, or we could start translating this to algebra. I need you to come up with expressions of how we come up with these numbers in each column. Okay? Knowing that I start at 20 and work down, knowing that I start at 40 and work down. So for this guy, you start at 20, and then every time you move down the list, what are you doing? You're adding 1, so we need a variable with it, so we're adding 1x. And then how do you move down this list? You start at 40, but you subtract x every time. Very good. And we know from our calculations that if we multiply these numbers together, we get our revenue. And they want us to maximize our revenue. Ladies and gentlemen, it's time for your calculator to step up. Go to Y1. Don't even simplify it. He doesn't care. Plug that nasty thing into the calculator, and we're going to need to adjust the window.
You gotta use parentheses.
Yes, please use parentheses. Was it 20 plus x and 40 minus x? Cool. Now, sometimes you luck out. If you use your last window, you might be like, oh, cute, it worked. Yeah, this was not one of those moments. This window does not work at all. So go to window. We need to pull back all parts of your window, a whole bunch. Guys, X represents the number of cases that the person is selling. And if you remember, one of those expressions was 40 minus X. So you're not going to be able to go any bigger than 40, right? So can we just call X as 0 to 40? And then as far as revenue goes, like I can tell you for sure 15,000 was way too big. So you can either pull that down yourself or you could try zoom fitting right now. Let's just pull it down ourselves, guys. Like 1,000? Don't you think that should be good? I don't know. Try 1,000. Let's graph. Oh, that's beautiful. So if you didn't catch that window, it was 0 to 40 for X's and 0 to 1,000 for Y's.
How would it be 1,000?
Because it's revenue that they're calculating on the Y component. So remember, we were getting numbers like 800, 840. Yeah, I kind of took a stab at 1,000. But all right, guys, find the maximum, please. And then we have to translate what that maximum actually means. All right. I'm going to hop over to 5 for the left bound. I'm going to hop over to 15 for the right bound, just in case. Ooh, that was dangerous. All right, and then middle. All right, so you're getting an ordered pair of 10, 300. And here comes the most frequently missed question on the homework.
Why did I get 900?
Oh, it's 900. I can't read. 10, 900. Y'all, you're so used to saying X equals 10 and then walking away and being like, boom, got it. What does the question say? How many stores per week should she visit? 30 is the answer. Yeah. Stores per week is 20 plus X, so 30 stores. And I know this is a really weird and boring looking example, but this actually, analytics is a huge field you guys can get into and make tons of money. They do it on a much grander scale than this, but companies will hire you, say like maximize my profit, minimize my cost, and it's all based in like mathematical simulations. It's kind of awesome. Do that, make a lot of money, and come back and tell me how cool you are. And then you can donate to my child's college fund, okay? With all your money that you have sitting around. All right, a potter can sell 120 bowls per week at $4 per bowl. For each 50-cent decrease in price, 20 more bowls are sold. But think about this, guys. If they keep decreasing their price, at some point their profit's going to suffer because they're not going to charge enough for it, right? So let's see. They started with 120 bowls for $4, and their revenue, of course, is us multiplying this together. But if they decrease by 50 cents, so now it's $3.50, that's a 5, they're going to increase this by 20. So what's that, $4.90? So I'm kind of sick of coming up with examples. Can we just jump into the algebra?
Yeah.
Thanks. So agreeable. Tell me how to come up with, starting at a 120, how do we keep coming up with the next number and the next number and the next number?
Plus X.
Plus 20x. You see it? It's
Okay.
jumping by 20s every time. So how about this? We start at 4, and we're subtracting 50 cents each time. So minus 0.5x. Good. All right. We're a little short on time here, guys. So we would type this into y1. We'd find our max. Turns out we'd have to adjust the window a little bit from the last question. Always try on your homework to not adjust the window at first and just like hope that it works, but then adjust it when it doesn't work, okay? The maximum actually is at the ordered pair 1, 490. So don't go running up to me and saying X equals 1, done, because that's not the question. The question is, what price should she charge? So it turns out this one I wrote in red actually was the maximum profit for her. So plugging in an X equals 1, she should be charging $3.50. Okay. So there's some homework questions on worksheet 9 on the back of it that you guys are going to finish that look a lot like these. These are difficult, so I expect you guys trying them and coming in and asking questions. All right, time to do our retake on complex. Bye, world.